What happens when a fiercely independent neutral nation decides to spend $4 billion overnight to buy a foreign fleet of warships? On May 19, 2026, Sweden sent shockwaves through the naval defense community by completely bypassing British and Spanish rivals to order 4 next-generation digital frigates from France. Stockholm was forced into this corner because the worsening security environment in the Baltic Sea left them with zero room for error and an urgent need for advanced anti-submarine defenses. But how did France manage to secure this massive contract while simultaneously launching their second brand new vessel named Admiral Luzo? The answer lies in a radical construction philosophy that traces its roots back to the height of the Cold War. To survive a terrifying standoff against the Soviet Union, Paris did not just build ships, they engineered a fortress capable of operating in the middle of a nuclear apocalypse. This was the birth of the Type F-70 Georges Leygues class destroyers. These vessels were not just designed to hunt Soviet submarines, they were built with an airtight citadel pressure system and automatic washdown systems to flush away radioactive fallout while navigating through a nuclear blast zone. It is the exact same DNA of extreme survival and modular design that France has now reincarnated into their 2026 digital fleets. Before we go on, did you expect Sweden to choose a French warship design over its traditional partners? Smash that subscribe button to join our global defense community and tell me where you are watching from. To truly understand why the defense world remains stunned by this platform, we have to look back at the desperate geopolitical crisis that forced France to innovate far ahead of its time. To understand the true genius of this design, we have to look back to the mid-1970s, when the French Navy faced a dangerous capability gap. Following President Charles de Gaulle's decision to withdraw France from the integrated military command of NATO, Paris stood completely alone. The entire French strategy of nuclear deterrence relied on its brand new ballistic missile submarines, like Le Redoutable slipping silently out of the Brest naval base. However, the Soviet Union had deployed a massive fleet of fast attack submarines directly into the waters of the North Atlantic, with one single mission to shadow and eliminate French nuclear submarines the moment they left port. France desperately needed a fleet of ocean escorts capable of hunting these Soviet shadows, but they could not afford to match the massive ship production numbers of the United States or the Soviet Union. This critical pressure birthed the Type F-70 program. Instead of building massive, expensive destroyers, the French Navy built a compact 4,500-ton workhorse optimized for asymmetric warfare. At the heart of this survival strategy was the installation of a high-tech combined diesel or gas propulsion system. By pairing 2 smooth SEMT peel-stick diesel engines for quiet, economical cruising with 2 massive Rolls-Royce Olympus gas turbines generating 52,000 horsepower, the Georges Leygues class could instantly sprint at 30 knots to intercept an underwater contact. More importantly, they introduced the CNIT 4 combat management system, which was one of the earliest digital architectures to automatically process and coordinate sonar data in real time. Paris had successfully engineered a platform that maximized naval power while minimizing hull size. Yet, as these vessels sailed into the freezing waters of the Atlantic, the crews quickly realized that pushing the boundaries of technology would force them to confront a terrifying new vulnerability under the waves. The ultimate weapon of the Georges Leygues class did not sit proudly on the deck, but was dragged hundreds of meters behind the ship deep beneath the waves. This was the Thomson Sintra DUBV low-frequency variable depth sonar. While standard hull-mounted sonars were completely blinded by the thermal layers of the ocean, this heavy acoustic sensor could be lowered directly into the deep thermocline zones to expose Soviet submarines attempting to hide in the deep water. To neutralize these targets, the destroyer operated as a tight team with its 2 onboard Westland Lynx helicopters, which dropped acoustic sonars and launched lightweight torpedoes from miles away. Yet despite this brilliant acoustic framework, the initial design possessed a critical blind spot that real-world operations quickly exposed. To minimize the radar cross-section and lower the center of gravity for maximum blast resistance, the first 4 ships were built with an extremely low bridge profile. However, when sailing into the brutal storms of the North Atlantic, giant waves smashed directly onto the bridge windows, leaving the officers completely blind during high-speed maneuvers. French engineers were forced to raise the bridge structure by several feet on the final 3 vessels, trading away a portion of their nuclear protection for basic operational reality. More terrifyingly, the primary close-range weapon of the ship carried a hidden danger. The destroyer carried the L-5 anti-submarine torpedo, which had an incredibly short range of only 9 kilometers. In the chaotic noise of an explosive battle or a nuclear wave disruption, the primitive passive sensors of the L-5 torpedo could easily lose track of the enemy and turn around to lock onto the loud acoustic signature of its own mother ship. The crew lived with the constant anxiety of being destroyed by their own weapon. Despite these terrifying technical risks and extreme engineering trade-offs, the Georges Leygues class served as the unbreakable shield of French naval diplomacy for over 40 years. When the final vessel, named La Marque Piquet, was decommissioned a few years ago, it marked the end of a legendary Cold War era, but not the end of its strategic legacy. The radical modular philosophy and the advanced acoustic systems perfected on those retrofitted hulls provided the exact technological foundation for the multi-mission FREM frigates and the brand new defense and intervention digital vessels. Sweden's massive $4 billion contract and Greece's heavily armed fleet are not just buying modern steel, they are purchasing 50 years of hard-earned French anti-submarine mastery. By standardizing these compact digital warships across Allied fleets, Paris is successfully weaving a synchronized wall of defense across the Baltic Sea and the Mediterranean. More importantly, by deploying these rapid, agile vessels to protect European waters, the French Navy can finally free up its heavy nuclear aircraft carriers and destroyers to project power much further away. This strategic shift allows France to secure its vast overseas territories and maintain continuous freedom of navigation operations inside the vital Indo-Pacific region, without relying on the logistical umbrella of the United States. The true lesson of this naval evolution is that ultimate maritime survival belongs to whoever can innovate and adapt the fastest. True independence requires the courage to build radical platforms far ahead of their time. As we look toward a highly volatile 21st century, you believe that France's fully digitalized software-driven fleets are truly ready to survive the brutal realities of high-intensity conflict, just like their nuclear-resistant ancestors did. Let us know your thoughts in the comments below.